Okay, we're continuing with our functions, and today, while we make it maths, of course, we're going to be looking at exponential functions. Now, for our exponential functions, we've only got 2, and then you're going to draw 4. Now, for these, they're starting, look, it's a little baby. So, our baby exponential, we've got, there we go, is x, y, right? Our Cartesian plane we're going to need. Now, for our exponential like this, as we put in bigger numbers of x, so the output's going to increase. So let's have a look. What's like 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. So as we're putting in bigger values of x, so the output's increasing. So this is an increasing function. Like with straight lines, we went, hey, it's a positive gradient. We can see that this is increasing. And if we put in 2 to the 0, well, what's anything to the power of 0? Well, it's 1. So it means that what we worked out there is 0, 1 is on the graph. There it is over there. 0, 1. We said it's increasing. So our graph, we should just remember, looks something like that. And I say remember because, this is just one of those, like, what your basic parabola looks like. And let's choose another number like 3, 8. So we said this number like here, 3, 8 was on the function. Cool. Now, part of what we've been doing is inverses, right? So let's look at the inverse function. So algebraically, this is y equals 2 to the x. So for our inverse, and while I remember, let me label this one. So for our inverse, we're going to go y equals 2 to the x. So x equals 2 to the y. Now I'll leave it to you to do the algebraic manipulations. We got it in the form y equals. But let's just focus picture, visually. So remember, this is a reflection about the line y equals x. So if we drew our straight line here of y equals x, this graph didn't cross it ever, so therefore our inverse isn't. What was x is y, what is y is x. So 0, 1 reflects across to here to be 1, 0. This line 3, 8 should actually have been like over here somewhere, but anyway, reflects across and goes here to 8, 3. Now, one thing with our exponential maybe we need that will be useful is no matter what input we put, it looks like we always got a positive output. There's actually an asymptote across here at the line y equals 0. Because look, if you put in smaller numbers, it gets closer and closer and closer to the y-axis, to the x-axis, but never gets there. So at y equals 0, there's an asymptote, which means that in our inverse function, over here, there was a y equals 0 asymptote, so now there's an x equals 0 asymptote. Remember, it's x is y becomes x. This graph here is increasing, so our inverse function is also going to be increasing. Link up, increasing. So it's still increasing. Now there's only real one way we can draw this graph. It needs to go through this point 8,3, and it needs to go through this point 1,0. In our original function, y was always positive. So in this function, x must always be positive. So it must take this shape over here. Notice it's getting closer and closer to this asymptote. Right here, getting closer and closer, but never touches it. X is always positive, because in the original function, y was always positive. Label our function must look like that. Okay, example 2, still a bit of a baby in terms of the exponential, but their inverse is new. So let's draw this down. Set of wonky axes, x, y. This graph, remember this is just another way of writing y equals a half to the x. Now this one, it's a fraction, so as we put in bigger numbers, so let's put in like f of 0. Well, that's a half to the 0. Well, what's anything to the 0? Now we've been through this, right? 1. So that there is the point 0, 1. Now, if we put in like f of 1, well, a half to the 1, that's just the same thing, right? It's going to be a half. So when we put in 1, it went down to a half. It went like there. And then, well, actually, it went down there. But okay. And then f of 2, well, a half squared gives us a quarter. So all of these things were telling us coordinates on our graph. 0, quarter. And what it's telling us is that as we put bigger inputs in, the output's getting smaller. So this is a decreasing function. So this one here is going, oh, come on. This one here is going like this. But the output again is never going to be, that's a terrible exponential, isn't it? But the output here is never going to be 0 either. So we still got our asymptote here at y equals 0. Okay, ready to hit our inverse function. So our inverse function reflects about the line y equals x. So there's our line y equals x. Whatever was x is y, whatever is y is x. So for our inverse function, this is going to come across and be over here. 1, 0. It must go through this point here because it's crossing the line y equals x. And this one's decreasing. The inverse also needs to be decreasing. Our original function had an asymptote at y equals 0. So this has an asymptote at x equals 0. Whatever was x is y, whatever is y is x. Reflects about the line y equals x. So it must be decreasing. And it must never reach here. So we couldn't draw it like we drew our last one because how are we going to put it through both of these? Must get closer to y. So this one's going to be decreasing. It's going to be there. It's going to be getting less and less and go through like that. There's our inverse. And our original function was given over here. There's a point of intersection over here. We're not going to find this point of intersection, but there is a point of intersection. So just think, decreasing, decreasing. What's x is y, what's y is x. So again, as our final piece of the puzzle, for our inverse function, we're going x equals a half to the y, blah, 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 some algebra, and y equals, and you'll put in that form. So leave that for you, as well as the exercise for these. Just my hint for this one and this one as well. You can't multiply these. Not 2 times 3. So not 6 to the x. It's 2 times 3 to the x. So they're the ones to do. And as you do it, just think to make it maths.